So today we are going to discuss about finding the GCD or HCF by using Fundamental Theorem of Arithmetic. How can we use the Fundamental Theorem of Arithmetic into finding the GCD or HCF? So according to Fundamental Theorem of Arithmetic, we can write any number in this fashion: n equals 2 power a, 3 power b, next prime number is 5, next prime number is 7, another is 11, like that. We assume two numbers, that is n and d, and we are trying to find out the GCD of n and d. Okay, the GCD of n and d. So we write n is like this, and d as 3b2, 5c2, and 7d2, 11e2. So according to Fundamental Theorem of Arithmetic, it is said that the GCD of n and d would be 2 powered the minimum of a1 and a2, and 3 powered the minimum of b1 and b2, and the 5th power of minimum of c1 and c2, and so on and so forth. So this is very easily explained, the GCD of any number, using the Fundamental Theorem of Arithmetic. Let's take an example. Suppose one number we have is 126 and another number we have is 600. So 126 in its prime factorization looks like 2 powered 1 times 3 power 2 times 5 power 0 times 7 power 1. And 600 in its prime factorization, when we break it down to the smallest possible numbers, those are the prime numbers. So we get 2 power 3 times 3 power 1 times 5 power 2 times 7 power 0. Alright, so 126 and 600. So the GCD therefore of 126 and 600 would be, we will write 2, the minimum between 1 and 3, and 3 powered the minimum between 2 and 1, 5 powered the minimum between 0 and 2, and 7 powered the minimum between 1 and 0. So therefore the minimum between 1 and 3 is 1, minimum between 2 and 1 is 1, 5 and 2, 0 and 2 is 0, 1 and 0 is 0, so the answer is 6. There you go. So the GCD of 126 and 600 is 6. Let us take another quick example. Say one number is 10, the other number is 45, and if we do the prime factorization of 10, we get 10 is actually 2 times 5. So therefore we can write here as 2 times 1, 3 times 0, 5 times 1. And for 45, similarly, 45 is 9 times 5, and 9 can be broken down again as 3 times 3. So therefore for 45 we will write as 2 power 0, 3 power 2, 5 power 1. So what is the highest common factor or GCD? So we will write 2, 3 and 5. What is the minimum power of 2 between 1 and 0? So it is 0. The minimum power between 3 power 0 and 3 power 2 is 0 again. The minimum power between these two 5s, we have only 1. So the GCD of 10 and 45 is therefore 5. Let's go back to the same two numbers that we have assumed before, the n and d. And now earlier what we have done was that we have chosen the minimum power, the minimum of a1 and a2, b1 and b2, c1 and c2. So when we choose the minimum, we get the highest common factor, or we get the GCD. But what happens if we take the maximum? So for example, let's see, we write here as 2 power max of a1 a2, 3 power max of b1 b2, 5 power max of c1 c2, and 7 power max of d1 d2. What do we get? This time we get the LCM of n and d. If you take the minimum of the powers, you get the GCD. If you take the maximum, you get the LCM. So let us check this with an example. We take the earlier example 126 and its prime factorizations are 2 power 1, 3 power 2, 5 power 0, 7 power 1, and 600 is 2 cubed, 3 power 1, 5 power 2, 7 power 0. If you are trying to find out the LCM of 126 and 600, so we will write 2 and we will try and find out the maximum power between 1 and 3, and 3 powered the maximum between 2 and 1, 5 powered the maximum between 0 and 2, and 7 maximum between 1 and 0. So the maximum between 1 and 3 is 3, maximum between 2 and 1 is 2, the maximum between 0 and 2 is 2, maximum between 1 and 0 is 1. So this is the LCM of 126 and 600, and it is 12,600 is the answer. Now the GCD of 126 and 600 was 6, and the LCM of 126 and 600 was 12,600. What happens if we multiply both of these numbers? What do we get? The number that we will get will be equal to 126 times 600 itself. So the GCD of a number A and B times the LCM of a number A and B is actually the product of those two numbers itself. Let us try and find out what is the LCM of 10 and 45. 10, when we break it down to their prime factors, so we get 10 as 2 power 1, 3 power 0, 5 power 1. And when we break up 45, we get 2 power 0, 3 square, 5 power 1. So to find out the LCM of 10 and 45, we write 2 to the power of the maximum power. The maximum power here is 1. 3, the maximum power is 2, and 5, the maximum power is 1 itself. So the answer is 90. So 90 is the LCM of 10 and 45. Thank you. To recap whatever we have studied until now, we take any two numbers and break them down into their prime factors. So that is the fundamental theorem of arithmetic. And then to find out the GCD of those two numbers, we compare their minimum power. So what is the minimum power over 2, the minimum power over 3, the minimum power over 5, and so on and so forth, as much as there are. And to find out the LCM of both of the numbers, we take the maximum power. The maximum power of 2, the maximum power of 3, the maximum power of 5, and so on and so forth. So that's it for today. I hope you have enjoyed. Thank you so much.